Okay, hi everybody. We are going to do some mathing. We're going to do section 11.4, page 737. This is like my third video today, so I'm a little bit like, whoa, my eyes are crossing. And so hopefully I will actually be able to explain to you what we're doing in section 11.4. So page 737, 11.4, we're going to do Pythagorean theorem. Pythagorean theorem is a formula that works on right triangles only, no other kinds of triangles, only right triangles. So Pythagorean theorem, this is a leg, we'll call it A. This is a leg, we'll call that one B. This has a special fancy term. It's the longest part and it's across from the right angle. And shocker, we're going to call this one C. Okay, I know, it's amazing. So in the Pythagorean theorem, I think you've seen it before because I'm pretty sure I taught it in 8th grade math. It's a squared plus b squared equals c squared. Remember, the legs have to go here and here. Doesn't matter which one goes where because they get added together, so it doesn't matter. This always has to be the hypotenuse. Okay, so for example, number 1, they tell you that this is 6 and that c is 7, and they want you to find a. So we don't know a. We plug in our b squared and our c, and we square that. So let's go ahead and fill that in. That would be 36. That would be 49. Now we have to solve for a. So we're going to subtract our 36. A squared is going to be 13. Okay. Now, we've been doing this now for a little while in algebra. To get rid of a square, what do? We square root. So we square root and we square root this. So our answer is whatever the square root of 13 is. Notice they left it as square root of 13. Okay, that's because the directions didn't tell us any sort of decimal information or anything. So they left it just like that, which is fine. Okay, Pythagorean theorem. So that's how you do it. If they give you straight numbers, you just fill in the ones that you have and solve for the one that you're missing. Let's look at one where they don't give you actually specific numbers, like example number 2. A right triangle has one leg that is 2 inches longer than the other. So one leg that's 2 inches longer than the other. Whoopsie, I think I'd actually like to draw this how it's supposed to be. If there's one leg, this leg it says is 2 inches longer than that leg, right? Okay, and then it says the hypotenuse is root 10. So there's my triangle. Draw it if you need to. I always draw pictures in math because it makes it easier for me to understand. So go ahead and draw it if you need. We're going to do Pythagorean theorem. Remember, we're going to do one leg squared plus the other leg, which looks like this, squared, equals the hypotenuse squared. Okay? Remember, the longest part is the hypotenuse. It always is the one that goes by itself. X squared can stay like that. This, I know a lot of you want to do it wrong because I remember that from when we actually did in class. Remember, this means you have 2 of them like this, and you have to end up foiling that, okay? If you have a square root that gets squared, it cancels out. It's just 10. So let's go ahead and FOIL. Firsts, x squared. Outsides, 2x. Insides, 2x. Lasts, 4. Okay? We're going to combine any like terms that we have. I have an x squared and an x squared here. So how many x squareds is that? Since we're now adding, we don't multiply. We just say, oh, how many of these do I have? Okay? I'm going to move over here. So I have 2 of those. Okay? And then I have x's right here. How many x's do I have total? I got 4 x's. And then I have my regular number here and another regular number here. Probably it would be a good idea if we got all the numbers on one side. So let's minus 10 from here, okay? And minus 10 from there. If I have a 4 minus a 10, what do I have now? Negative 6. So here's my equation right here. Now, all last chapter we did equations that look like this, and we found a lot of ways to solve them. I'm going to do it by factoring. The first thing I'm going to do is I'm going to take out a 2 because it makes it much easier to factor. So I'm going to divide everything by 2. Then I'm going to factor. We have an x and a 3 and a 1, and it looks like we want to do a positive 3 and a negative 1. So when we solve, our answer will either be a negative 3 for this one or a positive 1 for that one. Now we have 2 answers. How do we know which one to use? Well, let's plug it in here. If I had a negative 3 plus a 2, that's negative 1. Is it possible for the side of a shape to be a negative number? No, not in any world that I know. So that one would not work, so I would want to go ahead and pick the 1 because that's the one that would work. Now, do they want us to actually put, let me see, find the unknown lengths? Yes. So this unknown length is x, just x, and x is 1. This unknown length would be 1 plus 2, which would end up being 3. So those are our unknown lengths. Why did I not write this one down? Because I already knew what that one was. It wasn't unknown. Crazy. Okay, that's it. That's Pythagorean theorem. Bam, done. The only other thing they show you there on example number 4 is tell whether it is a right triangle. So for those, you simply plug your numbers in. Let's look at example 4, letter A, okay? 8, 15, and 17. The longest side is always the hypotenuse. So plug it into the Pythagorean theorem. You can see they did that there. 8 squared plus 15 squared equals 17 squared. And they did all the mathing with their little calculators. And they saw that one side was 289 and the other side was 289. If those two sides equal each other, you say, yes, it is a right triangle. On B, when they did it, the two sides did not equal each other. So when they do not equal each other, you would write, no, it's not a right triangle. It's only a right triangle if the numbers work in the Pythagorean theorem. Okay, then example number 5. It's just a word problem about a construction worker. Do this, and they're marking, I would have to draw a triangle so I could visualize which parts are which. They just want to know, will this work? So they take their dimensions that were given in the word problem, plug them into the Pythagorean theorem, see if it works, if one side equals the other side. For the Pythagorean theorem to work, this side has to equal this side. If it doesn't, it's not a right triangle. Not a right triangle. Okay? I think that's it. Yeah, that's it. I think you're good to go. Have fun. Pythagorean theorem is awesome, and you'll use it all the time in geometry. So become very familiar with it. It will be your friend. Okay, see you later.